Thank you, Mike. I'd like to introduce Ming Xiao, who is with Penn State University. So I'm not sure, but probably a little bit tired. He flew in yesterday. It's quite a long trip. I haven't made that myself. So with that, I'm going to turn it over to Ming, who's going to be talking about the vulnerability of permafrost and some of the work they've been doing.
Thank you, Billy. Well, today I want to talk about the Arctic Coastal Hazard Index. It's a kind of comprehensive framework for assessing the vulnerability of combined threat of permafrost thaw and coastal erosion and flooding in the northern Alaska coast. And this is work primarily done by my student Ziyi Wen, and also with collaborators such as Dimitri and Vladimir from UAF. Well, this work is funded by the Navigating the Arctic program of the NSF. And we can probably categorize the hazard of the Arctic coast into three major parts. One is the permafrost thaw induced ground subsidence, and then the other is land loss due to coastal erosion, and also inundation or flooding. There are some kind of index-based approach to analyze those hazards, such as the coastal vulnerability index, and considered 6 properties, such as geomorphology, coastal slope, and sea level rise, and the storm characteristics. And also some other approach, look at the inundation index or erosion index, or neuro index, considering different storm or the ground properties. But those methods really they don't consider explicitly the permafrost thaw, and we know the thawing permafrost and also the flooding and erosion, they are kind of combined integrated threats. So this kind of multi-hazard, if we have a way to kind of integrate all the threats into one kind of index-based, and then we can look at how this can affect communities, and then it can be used probably by policymakers or other decision makers. So, we focus on the northern Alaska coast and Beaufort Sea and Chukchi Sea coast. And then the approach is includes multiple steps, and I have only 15 minutes. Probably I will skip some of the detailed approach, but explain some of the main steps. Well, and we consider 2 time periods. One is present day, 2020s, and the other is 40 years from now, 2060s. Under 2 climate forcing. One is RCP 4.5, the other is ICP 8.5, and here shows the mean ground average ground temperature, and here shows the active layer thickness variation at present day, and that's 2060s for the RCP 4.5 and this RCP 8.5. Well, the work used the Geophysical Institute Permafrost Laboratory model or GIPM model 2.0. And this is a part of the work that Dimitri did. And this is the concept. Well, in analyzing the ground subsidence, and we consider the thallic. And this is the concept explained to me by Vladimir. Well, basically, and this is the ground could thaw up to here in the summer, and then in the winter time, and the ground can freeze, but not freeze all the way to the potential thaw depth. And so, and this will form the kind of perennially unfrozen layer, we call it the thallic layer. And this is a thallic layer with a warmer air temperature, and this thallic layer can gradually grow in thickness and with the years. So, and in the ground substance analysis, we cannot just consider the active layer thickness, which is the freezing thaw, but also we have to consider the perennially unfrozen layer, which is thallic layer. Now, and this is the substance index, and we consider the combined thickness of the thallic and active layer, and also this also the substance depends on the volumetric ice content. And here shows the and this is GIPL model and it shows the thallic thickness. And in 2060s for us to be 4.5, and this is 8.5. Now, and first we used the existing work to look at the hazard index, or HI, for the Arctic coast. And this approach was used in the temperate regions. And this approach was initially used by Akiba in the 2013 work. And here considered 7 different properties, including the habitat, the shoreline type, and the relief, wind, waves, storm surge potential, and sea level rise. And each of this they can be categorized into index, which is 0 from 1 to 5, and then each value is 1 to 5, and then the multiplication of that, and then we look at the hazard index, and get it to put to the power of 1/7. So this HI is also in the category of 1 to 5. Now, and then we analyzed the ground thaw induced substance. We call it permafrost thaw potential. And then the permafrost thaw potential can also be categorized into 1 to 5. And for example, and 1 could be from 0 to 5 centimeter, and 5 to 15, 15 to 25, and so on. And then 5 would mean that the ground substance is over 35 centimeter. And then using this R, which is also a value from 1 to 5, and then times the hazard index over here that we derived, and then we can find out the Arctic coastal hazard index. And here you have to skip the approach that we used different database that published and that particularly applies to the Arctic coast to derive all the different parameters, and so that we can input into finding out the hazard index. And then considering the thaw, then we kind of combine the erosion and the permafrost thaw into a single parameter, right? So here shows the some of the results. Now this is the thaw subsidence, and here shows the RCP 4.5, climate forcing, and this is in the 2060s compared against the present day, and this shows under increased climate forcing scenario, and then at 8.5, and you can see there's a more ground substance in some places. The ground substance is higher, 35 centimeter and over a foot. And we'll also find out that mainly the distribution depends on the ground ice. The ground ice is also associated with other characteristics of the ground, and also the environmental factors. Now, with that, and with the ground subsidence, and we can categorize this into kind of index based, and from 1 to 5, and 5 being the highest. And but before we do that, and we want to validate our thaw prediction. So here is, and this is the thaw prediction by the GRPL model, and this is the 2060 annual RCP 8.5. And if we look at just a small region, zooming in this small region, this over here, this is the index prediction. And then we look at work from Liu et al. And they used the INSAR observation. And here shows the same region, and this shows and within just a decade, and the ground soil substance is from 0, which is no substance, to 4 centimeter. And then the ACHI prediction, and also follows the same range, and also the distribution, and it kind of matches matches the current observation. So with that, and we input that into the Arctic coastal hazard index, And then from this range from 1 to 5, and we put it into 4 quartiles. And so we can call it stable, low, moderate, and high. So this is the coastal index, and we take each pixel represents 1 kilometer square region. So here shows the prediction in the 2060s under RCP 4.5, and here shows RCP 8.5. And you can see clearly that with the increased climate warming, and particularly at the western Beaufort Sea, and over here, and it's from kind of Wainwright to Point Lane and coastal regions. There's also accelerated hazard, and this combines both ground subsidence induced land loss and also coastal erosion. So we also try to validate our results, even though the data are quite limited. So here shows the observed data that were published by Lantut in 2012. Here shows the in the same region that we studied, and this graph shows the assessed coastal hazard and published by USGS. And here is the and this is published in 2017. And this is the predicted result in the 2060 and RCP 8.5. At least we can see that the distribution of the combined hazard is matched relatively well. And as you can see, this particular in the west and coastal region of the Beaufort Sea that matched of the assessed data from USGS and also the observed data and published earlier. Well, in conclusion, the ACHI is a useful tool that we consider, not just erosion, but also the ground subsidence that can also, combine with erosion. And if we use the data that, particular for a certain region, that we can predict what's gonna happen, and this could be a useful tool and for people to assess the combined hazard. And so the work is kind of preliminary validated, and so that we could use that and with certain confidence. But there are some limitations of this work, and here for example, it is not, and the resolution is still pretty coarse, and we look at 1 square kilometer.
2 minutes.
Oh, okay, sorry. Now this is actually the last slides, and the ground ice mapping is still relatively coarse, and within that square kilometer, we don't know, and the difference with that. And the accuracy is also limited by the sparse data such as vegetation, organic layer, lithology, and so on. Really, the model's accuracy depends on the input data. And sea ice, we did not consider the sea ice, and in wintertime, the ice could probably reduce the coastal erosion, but that was not considered because of the relatively sparse database. We also did not consider the barrier island, which is kind of protective layer for the coastal region, and also the we needed really more ground observations and to further validate our results. So and this is some of the collaborators, and this work is on the right hand side. Any questions?
Yes, very interesting, particularly your mapping of the ground settlement index across the average. I'm really impressed about it. But my question is relative to coastal erosion. How much weight has ground settlement relative to coastal processes in your ECHI model?
Well, we kind of follow this approach that, we consider, and each one is, you know, how do you say this, 1/8 of weight, and then we combine those two, and so this, all this takes the weight of half. So we consider the ground subsidence really more important, and then each of the individuals, such as the wave and the duration of the storm. So this is one parameter after this. It is HI, and the permafrost thaw potential is the second parameter. Takes another 50% of the weight.
Another 50. How much you say?
50%.
50% here in the model.
Of the importance, model.
Thank you.
Colleen?
Thanks, Lynn, for that talk. Can you go back to the maps that near the end of your slide, the ones where you map the potential coastal erosion? Yeah, these. So I'm trying to wrap my head around these really quickly, and it would be helpful to have the communities mapped on this so we could place them exactly where they are.
So I should have an earlier, as you see, in our AA project, and we had 4 communities, and Utiqiagvik, Wainwright, Ponley, and Utiqiagvik.
Yeah.
And here's Blue Bay, but the other map I didn't.
Yeah, if you could go back those, because I'm just trying to think. So I'm just trying to think about where the communities are in my head, as far as I know, and it's interesting to see the areas with the highest potential seem to be where the communities are placed, where they are right now. Am I kind of thinking that? So except for I'm just trying to
Utiqiagvik, Wainwright, and Ponley are kind of off the high hazard area.
Wainwright is not high hazard.
Yeah.
This is Wainwright.
Is it closer to the Cape than I thought it was kind of in the middle.
It's in that little, 4 pixel area, just.
Okay.
So this is the this is Ponley. Right? This is the
Well,
Wainwright.
I think Ponley's further down. Yeah, Ponley, down there, yeah.
The coastal erosion Ponley, we know is really not an issue. It's mainly it's from subsidence.
Yeah, so I think just I'm just trying to figure out how knowing where the communities are, this, there might be an added layer of complexity here too in terms of infrastructure and kind of human disturbance on the environment as well. Or maybe there's a selection of sites that were preferable for people to live there in the past. So I think there might be a human element missing that might be really important to consider in understanding the coastal hazard potential.
Okay.
There's DOT infrastructure costs here.
There you go.
It's not represented.
Yeah.
There's 611
Yeah.
warning stations all across here.
Yeah.
Okay.
So I think thinking about the kind of human built environment might be really interesting to think about here as well.
Okay. Thanks.
We're gonna have to cut this off at this point in time.
Well, we have time for, I have to load Lynn.
Oh, okay, go ahead.
So we have time for one more question.
Go ahead.
Okay, so I understand that this is an index-based hazard map. But my question is, the erosion and exactly this kind of hazard is basically driven by physical processes, right?
Right.
And they are not necessarily, as Michelle pointed out, weighted the same way. So there could be locations which are much prone to what the ocean is doing, and not so much what permafrost is doing, or even the other way around. And when you create this kind of hazard map that is not taken into account this physics that we understand how it works, that maybe areas pop out pretty red, that in reality may not, which might create panic, even so it's unnecessary. Or the other way around, you consider things safe, but they are not. And my question is how that goes back to putting the human context in there, that it can be actually really dangerous, and putting too much effort in saying, okay, this kind of index, which is nice to have as a first order estimate, but placing that directly to people creates a perception of I'm safe or I'm at risk, which can become difficult.
Or decisions can be made off of it too, right? From looking at
Right.
our planners over here.
Yeah, but if the base is maybe
Yeah.
shifted and biased,
Yeah.
because this is an index-based approach, not a physical approach.
Well, actually, well, the approach itself is physics based, and with all the data that we can consider.
I understand that, but your combination in creating.
That's a really good question, and you know, we equalize those, you know, important. Some part maybe erosion is more important. So the weight we assign that currently is equalized, but may not be the actual case for a particular community. So, yeah.
But I can add to that, we went through this with the the Environmental Threatened Communities Project, where it was just desktop, that's all we could do, we could not go out to the villages and visit them. And so we had to make a decision, we had to make an assessment, and we had to prioritize the rank or whatever you want to call it, that was even tough, coming up with that proper word. But you just have to say upfront that this is unvalidated. And that you have, if anybody, any reader that's reading this needs to understand that further information needs to be gathered. That disclaimer has to be put up front. So it's all you can do, really. I mean, you have to come up with some method of ranking things. I'm sorry.
Can I just make one more thing, because I know you're trying to get to the next topic, it's quite critical to have scientists in the room for these conversations. Because these topics are really important, because you can say that these are invalidated, but, you know, if that's not read, if that page isn't read or whatever, like, having social scientists in the room is critical.
But what do you do?
I mean,
I mean,
that's
you
why
have
social
to
scientists
you have to
are
start somewhere.
I
So-
agree, but
so what do you do?
scientists can sit there and be like, this is how to communicate these things better and better ways and things like that. So-
Yeah, and you gotta start someplace.
So at least have historical data where you could use validation of at least doing regression on each one of your power components of your different elements of the index. And so that way you can get at least a rough sense of whether the equal weighting between one factor and all the other factors is appropriate, or even equal weighting.
It should be region specific.
Okay, I agree. This is a great conversation. It's a great conversation. That conversation needs to be had. I know Kevin and I and the Valley Commission had this discussion for hours. And we never really brought it to any conclusion. Perhaps, but we do need to move on. I encourage you.
We need our question ball back.
Yeah, I never need our question. Well, I encourage you, when we have some downtime, to get together and have this discussion, because it definitely needs to be had, and it's not an easy question as to how you interpret, all right, how you apply these types of criteria. And that's just the nature of the beast.
I'm sorry that